Hi everybody. So our next lesson is going to be about mass. But before we even talk about what mass is, let's see if we can remember what matter is, right? So we're looking at this cute little box of kittens, and in fact, matter is anything that has mass and volume. Oh, and my letters are all wiped out, but that's okay. So anything that has mass and volume is in fact mass. So let's move on to the next screen. So mass and volume, well, if you've done the volume station, you'll know that it's anything that takes up space. But in terms of what mass is in fact the amount of matter inside an object or a body, right? So if we're talking about matter, so we're talking about atoms and molecules, and even smaller than atoms and molecules. Anything that contains matter does in fact have mass. So how can we measure mass? Well, there's lots of different tools out there. There's some sensitive scales, a two-pan balance, a digital balance. And so you'll find that these are some tools you might see out in different types of settings or locations. In your classroom, however, you're going to be using something called a triple beam balance, and that's pretty typical in a lot of science classrooms across the country. Now, units for measuring mass. We're going to be using the SI unit, so the standard metric units, right? And so what that means is that we're not really going to be using English standard, so you wouldn't find things like the ton. Instead, we'd be dealing with things like grams and kilograms as appropriate. Now, when we're talking about grams and kilograms, what we would find is that 1 kilogram rather, is equal to 1,000 grams. So to change from grams over to kilograms, you actually need to divide by 1,000, and that's a pretty standard way of measuring. Next up, we might want to talk a little bit about, and get that to work, how we calculate the mass of an object. Well, what you'd have to do is you'd have to add up or sum what we call those standard masses, right? And here on a two-pan scale, right, if these two things are equal, they have the same mass. Here, the apple is a lot heavier than the sandwich, so therefore the apple has more mass. But what about a liquid, right? Well, if you take this Erlenmeyer flask and you put in some of this blue liquid and then you put that on the digital scale or the digital balance, you would have to subtract the mass of the empty Erlenmeyer flask from the total in order to know just the mass of the liquid. Because oftentimes you don't need the mass of the container, you need the mass of the material that's inside the container. So you'd have to do some subtraction. So if you're measuring any liquids at your stations, you need to think about that as subtracting the mass of the actual container, which means you probably need to know the mass of the empty container before you fill it with anything. That's always a good tip. Okay? Now, when we're talking about measuring mass, this is two-pan balance, right? If they're equal, then you know they have equal masses. But if I were to take away one of these blue weight discs, then you notice they would be unequal. The only way to make them equal is to add one back in. Does the mass change from one place to another? Good question. And in fact, the mass does not change from one place to another, even though it doesn't want to tell us that on this little demo here. It's getting stuck. Because if you think about it, whether you are on the Earth or on the moon, you still have a 1 kilogram mass. You still have the same puppy dog, so therefore the mass cannot change. All right? Those are some good little refreshers about mass. So see if you can find the amount of matter inside each of the objects at your station, similar to what you might do here. Thanks so much. Bye-bye.